Okay, if you have a quadratic in the form of ax squared plus bx plus c, okay, and you make y equal 0, then basically when that equals 0, that would be when you intersect the x-axis. Okay, so when you have a parabola and it intersects the x-axis, the possibilities are where it cuts it twice, it doesn't cut it at all, or it just touches it. You could also have the parabola going this way where it cuts twice. That would be where a is less than 0. This is where a is greater than 0. And also where it touches, like that, where a is less than 0. Okay, so if you're looking for values of x for which this happens, there's two spots here. These where the roots are real. These are real roots, and real roots. So once you've got they're the real roots, this one here is no real roots. Okay, so when you go to solve to get the x-intercept, x is minus b plus or minus the square root of b squared minus 4ac all over 2a. When you go to solve that, this part here underneath there determines what type of roots there are. That's called the discriminant. And with the discriminant, basically, if the discriminant is greater than 0 or positive, you could find the square root of it. So if the discriminant is greater than 0, you could find the square root of it. And so you'll end up with minus b plus or minus a positive value over 2a. So you get two solutions, minus b plus the square root of the discriminant on 2a, minus b minus the square root of the discriminant on 2a. That would be the same for this one, where you have two real roots. For these ones here, this is where we have one root. That's where the discriminant would equal 0. Now, if the discriminant equals 0, x equals minus b plus or minus the square root of 0 over 2a. So basically that part goes and you just get one real root. The type of parabola that's like that is one like, say, x minus 2 all squared. The type of parabola that's like this one is like x minus 1, x plus 2. Okay, when you have no real roots, the discriminant would be less than 0, because what happens is you can't find the square root of a negative, so you can't actually calculate a root. There's another situation where that happens as well, when the parabola looks like this, when it doesn't cut, and that's when a is less than 0, and this is when a is greater than 0. So basically you have real roots and unreal roots. Discriminant for unreal roots is less than 0 because you can't find the square root of a negative. Discriminant is greater than or equal to 0 for real roots. You have equal roots. That's where the discriminant equals 0 when you break this up into greater than and equal to. And you have two distinct means different, roots. That's where the discriminant is greater than 0. Okay, if you drew a picture of the parabola that fits this situation, this one here could be that, or it could be like that, where a is greater than 0, where a is less than 0. This one here, two distinct roots, it could be like that, or it could be like that, and that would be where a is greater than 0 and a is less than 0. Equal roots would mean that it would touch, would be like that, would be like that. And that's where a is less than 0, a is greater than 0. And real roots, you're either going to cut it twice or it's going to equal it. Okay, just further on this too, if you've got two distinct roots, the roots could also be rational and irrational. They could also be irrational. So irrational are like surds, pi, It's an irrational number. Rational can be written in the form as a fraction. So like 2/3, 4, 6%, they're all rational. But anything like root 3, root 7, they're irrational. So in order to have it be rational, it would have to have no surds. So if it has no surds, then the discriminant would have to be a square number. Because if the discriminant is a square number, then you can find the square root of it. An example of this, say I have x squared minus 2x minus 8 equals 0. We know we can factorise that and solve it, but if I went squared minus 4 times minus 8, discriminant equals 4 plus 32 is 36. See, that's a square number. You can square root 36, which is 6. So therefore the roots would be rational, which we do know, because if you factorise that, you would see that the roots are 4 and minus 2, which is rational.